Section 7.6 is talking about square roots and this Pythagorean theorem. Now, squares and square roots are opposite. If I take any number, x multiplied by x, I'm going to get x squared. So if we had 3 times 3, I get 9. If I take the square root of 9, which means what times what has to be the same number, equals the number inside the square root sign. So the square root of 9 then is going to be 3, because 3 times 3 is 9. So like on the example of 49, what times what is 49? Has to be the same number. Well, 7 times 7 equals 49. Therefore, the square root of 49 is 7. So what times what is 100? Has to be the same thing. 10, correct? All right, so squares and square roots are opposites. Okay, they're opposites, opposite properties. So we can combine these into fractions too. If we take the square root of a fraction, we can deal with the top, deal with the bottom. So what times what's 49? 7. What times what's 100? 10. So we can combine these two above into a fraction form, and then the square root is going to be 7/10 of 49 hundredths. Well, what if it isn't a whole number? These are called perfect squares because the number is a whole number, even the fraction. They're not decimals. Okay, so these are called perfect squares. Other perfect squares would be 25, 36, 16, 9. We did that. 4 is a perfect square. 2 times 2. 64, 81. Okay, those are perfect squares. 9, 8, 2, 4, 6, 5, and so on. Okay, well, what if it's not a perfect square? Well, that's when our handy-dandy calculator comes in here, and we just simply plug in the number inside the perfect square, and we hit our square root button. Okay, so we just hit that, and our perfect square comes out. But it's not quite perfect either. These are going to be approximate square roots. So 13.22, we're usually probably going to round to the nearest tenth on these. So we're going to say it is 13.2, and kind of do that little wavy line, which means approximately equal to. So 13.2. So we just hit the square root sign. Well, what if we have a decimal, and we're looking for the square root of a decimal? That's not a problem. Again, we're going to plug it into our calculator, hit our square root sign. So 3.66, that's going to round to 3.7. And we do the little approximate there, little wavy lines, not a problem. Large numbers, doesn't matter. They kind of throw those a couple in your example there. Rules don't change. Put it in, hit the calculator. 107.2, approximately equal to. Okay. What if we have these weird fractions? Well, we got to do an extra step to those. We need to decide what that is as a decimal first, because you really can't put, you can on some of the more elaborate calculators, but for our purposes here, we need to first convert this to a decimal. So we're going to take 5 divided by 22, and we're going to have 0.2272727. It's going to be a repeater. And then we hit the square root sign. So we take care of the fraction first, then hit the square root sign, and we're going to have approximately equal to 0.476, and we're going to call that 0.47, probably round to the nearest, or 48 rounding to the nearest hundredths. Okay, so take the top divided by the bottom, so we'll change it to a decimal, and then hit the square root sign on those when you see those in the homework. Square roots. Okay, the other skill that we have is Pythagorean Theorem. Pythagoreans were a group of mathematicians back in ancient times that got paid by the emperors and their leaders to sit around and think about mathematical properties. Well, they came up with a pretty good one. They noticed that if they had a right triangle and they took one of the sides, they call them those legs, and squared it, and they took the other side and squared it, it equaled the third side squared, and they called that the hypotenuse. So it really doesn't matter which of the two sides you call A and B for our theorem. The hypotenuse, though, is always going to be c. And the formula that you need to have in your homework is a squared plus b squared equals c squared. All right, so that means that we've taken a leg, squared it, taken the other leg, and squared it, and that equals the hypotenuse squared. So let's do problem 23 here and plug that into our formula and see how we can solve for c. Well, a is going to be the shortest side, and so I know that it's 6. They told me that, so I take 6 squared, I'll substitute. And they told me what b was, that's 8, so I'm going to square that, but I don't know c, I'm looking for it, so that's going to be c squared. Well, I can do the math here, because 6 times 6 is going to give me 36. I'm going to add it to 8 times 8, which is 64, and that's going to equal c squared. Well, 36 and 64 is 100, and that's still going to equal c squared because I didn't do anything with that because I just dropped it down. Well, I don't want c squared, I want c. And we talked about that these are opposite principles. Squares and square roots are opposite. So then we can take the square root of both of these numbers. Well, the square root of c squared is c, because c times c is c squared. And what times what's 100? 10. So now I've solved this by doing square root in order to solve this equation. So then in this particular problem, c is equal to 10. Well, let's say that we're looking for a instead of c. How do we do those? Well, we do them basically the same way. We fill in what we know. So we take our formula again, a squared plus b squared equals c squared. I don't know a, so I'm going to leave that blank. They told me that b here was 60, so I'm going to do 60 squared, and then they told me that c was 65. So 60 squared is 3600, and I'm not sure what 65 is in my head, so I'm just going to do it. 4,225 is equal to a squared. Well, that looks a lot like those algebra problems we were working on, doesn't it? We're working backwards. So we're trying to get the variable by itself, so we work backwards by clearing those out. So we're going to take away 3,600 from both sides. That's going to cancel. 25 drops down, and I'm left with 625. So now I have a squared is equal to 625. The next thing I have to do, right, I have to take the square root of both sides, because I want to get a, not a squared. Well, a times a is a squared, so a is the square root, and the square root of 625 is, if we're not sure, it's going to be 25. Well, let's put it in here. Just plug it into your calculator. Okay, and that's how we do those. A squared plus b squared is equal to c squared, and depending on which variable. Let's do one more of those. Okay, get another sheet of paper out here. Okay, this is problem 33 or 35, and we're missing b this time. So again, we're going to plug in our formula here. A squared plus b squared equals c squared. So our shortest side is always going to be a, or at least I like to make it a. It really doesn't matter a and b, but if we go the shortest, next longest, and always the hypotenuse is c. Always, always, always. So a is 15 squared. We don't know what b is, so we're going to leave that alone. And c, we know the hypotenuse is 60 squared. Okay, well 15 times 15 is 225, plus b squared equals 3,600. So as you can see, we've got to get b by itself, so we're going to take away 225 from both sides. So we're going to have b squared is equal to, we're going to have to borrow here, right? And that's going to equal b squared. Well, again, we don't want b squared. We want b, because that's the answer. Right, looking for b. So we have to do the square root of both sides. So b times b is b squared. So b pops out, which is exactly what we want. So 3375 square root is about 58.1. So it's 0.8 there on the calculator, so we're going to round that to the nearest tenth. And we're going to put that little approximate sign there. Alright? We could leave it as that if we want. Not going to hurt anything. We can round to the nearest tenth. Whatever works, but we basically have it right. Well, let's do one where it's a little bit harder to do. Let's do 36 right next to it. We've got a little time left on our video. They kind of keep us under 15 minutes here, so I kind of working in that principle for our length of our videos, if you hadn't noticed. Okay, so these numbers are the same. So we have a squared plus b squared equals c squared. So we have 18 squared plus 18 squared equals c squared. 18 times 18 equals 324 plus 324 equals c squared. So we're going to have 648 equals c squared. 648 square root 2545 is equal to c, because we took the square root of both of those, so we continue to work backwards. Gave us that. And again, that's going to be approximate. Alright? 455 might even be 2546 when you round. So that's how we do those. Go slow and easy. I'd write them out this way. I do the steps just like what we've done in class before for each of the videos. If you don't do anything, just simply drop it down. I think that keeps track of everything. And then that last step to clear out the square, you do square roots. Have fun with the homework.